Physics part 230. You should be able to represent an electric field by means of the field lines. You should be able to recall and use E is equal to V over D to calculate the field strength of the uniform field between charged parallel plates in terms of potential difference and separation. You should be able to calculate the forces on charges in uniform electric fields. You should be able to describe the effect of a uniform electric field on the motion of charged particles. You should be able to recall and use E is equal to Q over 4 pi E0 R square for the field strength of a point charge in free space or air. You should be able to define potential at a point in terms of the work done in bringing unit positive charge from infinity to the point. You should be able to state that the field strength of the field at a point is numerically equal to the potential gradient at that point. You should be able to use the equation V is equal to Q over 4 RE0 R for the potential in the field of a point, for the field of the point charge. Some effects of the static electricity are familiar in everyday life. For example, a balloon rubbed on a jumper will stick to a wall. A TV screen that has been polished attracts dust, dry hair, crackles, and may actually spark when brushed, and you may feel a shock when you touch the metal dome handle of a car on getting out. After a journey in dry weather, all these are examples of the insulated objects that have gained an electric charge by friction, that is, by being rubbed against other objects. Insulators that are charged by friction will attract objects. Some of the effects have been known for centuries. Greek scientists experimented with amber that was charged by rubbing it with fur. Or world's electron and electricity come from the Greek word NIEK-TPOV, which means amber. Today, electrostatics experiments are often carried out with plastic materials which are moisture repellent and stay charged for longer. Charging by friction can be hazardous. For example, a lorry which carries a bulk powder must be earthed before emptying its load. Otherwise, electric charge can build up on the tanker. This could lead to a spark from the tanker to earth, causing an explosion. Similarly, the pipes used for the movements of the highly flammable liquids, for example petrol, are metal clad, and aircraft moving through the air will also become charged. To prevent the first person touching the aircraft on landing from becoming seriously injured, the tires are made to conduct so that the aircraft loses its charge on touchdown. There are two kinds of electric charge. Polythene becomes negatively charged when rubbed with the wool. Cellulose acetate becomes positively charged also when rubbed with the wool. To understand why this happens, we need to go back to the model of the atom. Atoms consist of a positively charged nucleus with the negatively charged electrons orbiting it. When the polythene is rubbed with the wool, friction causes some electrons to be transferred from the wool to the polythene. So the polythene has a negative charge and the wool is left with a positive charge. Cellulose acetate becomes positively positively charged because it loses some electrons to the wool when it is rubbed. Polythene and cellulose acetate are poorly conducting plastics and the charges remain static on the surface.